In this question, there is a mosquito who is sitting on a disk, which is the LP record. This is a disk of a gramophone, and it is rotating with an angular speed of omega, where omega is equal to, it is given in revolutions per minute. So it is 33 1 by 3 rpm, which is also equal to 100 by 3 rpm rotations or revolutions per minute. Now if we wish to convert this revolutions per minute into radians per second, so we can multiply it with 2 pi in the numerator and with 60 in the denominator, because one rotation has 2 pi radians and 1 minute has 60 seconds. So this will be equal to 100, in fact 10 pi by 9 radians per second. So this is omega. Now there is a mosquito who is sitting at this position. This is the mosquito, and the distance of the mosquito from the center of the disk is 10 centimeters. Okay, so this mosquito is revolving in a circle of radius 10 centimeters. Okay, now we can say that there is a force which is centrifugal force. It is acting on this mosquito in the outward direction, where r is this radius, and this mosquito is able to rest with respect to the disk because the friction force will be acting on this mosquito in the inward direction. This is the friction. So we have to we can say that if this friction is balancing this mv square by r acting on this mosquito, this is the pseudo force, then this mosquito will be able to rotate in this circle with the disk. So now this in fact we can say that for rotation this friction should be at least greater than or equal to mv square by r. So this friction which is a static friction is equal to mu mg acting on the mosquito, and this is mv square by r. Now this mu will be greater than or equal to v square by rg, and this mu will be greater than or equal to v square, where v is the velocity of the mosquito, where v will be equal to r omega, and value of v square will be r square omega square. Therefore this is r omega square by g. Now r is mu should be greater than equal to, now this value of r is 10 centimeter, which is 1 by 10 meters, and omega is 10 pi by 9, and omega square will be 100 pi square by 81, and g is 10. So mu should be greater than or equal to pi square by 81. So we have to prove that, show that the friction coefficient between the record and the mosquito is greater than pi square by 81, which is the proof of the question. Thank you. In this question, you can see a system in which two blocks are connected with a string, and they are placed on a smooth cylinder. A string is ideal and the system is in equilibrium, which means we have to find out this angle theta. Now as simple as that the tension in this string T will be balancing M2G at this position, and the same tension T will be balancing this will be m1g sine theta. So t will be equal to m2g as well as t will be equal to m1g sine theta, and cancelling this g with g, so m2 is equal to 1 and m1 is equal to root 2. Now sine theta we have to calculate, so sine theta will be equal to 1 by root 2 and therefore theta will be equal to 45 degrees. Thank you. Now in the same question, if the values of m1 and m2 are different, m1 is equal to 5 kg and m2 is equal to 4 kg, and this system is released when this theta is equal to 30 degree, then we have to find out the magnitude of acceleration of m1. This is the m1 mass and this is m2 mass. Now let us suppose that this m2 is moving in the downward direction with some acceleration a, and with the same tangential acceleration a, this m1 will be moving in the tangential direction. This tension is T and this tension is also T because the string is ideal. Now this 40, I am writing the equation of this block, 4 kg block. So mg will be 40 minus T will be equal to 4a, the first equation, and a force of m1g sine 30 will be acting in the tangential direction. So we can write the equation of the m1 as t minus m1g sine 30 is equal to m1a. Now this t minus m1g will be 50, sine 30 is half, and that is equal to m1a, this is 5a. So if we add up these two equations, then 40 minus 25 is 15, and that would be equal to 9a. So a will be equal to 15 by 9. And if I compare this with n by 9, then n will be equal to 15. Thank you. In this question, it is given that there are two particles P and Q which are at a distance of Rp and Rq respectively from the center of a rotating disk, and we have to choose the correct options regarding their accelerations. So we can see that the value of, if this disk is rotating with an angular velocity of omega, then the value of centripetal acceleration of any point which is lying on the disk is r omega square, where omega is the constant angular velocity of this disk and r is the distance of that point from the center of the disk. Therefore, I can say that the acceleration of point P will be rp omega square and the acceleration of point Q will be rq omega square, and obviously is greater than rq, so ap will be greater than aq. So the option number 1, which is saying that both P and Q will have the same acceleration, is incorrect, and option number 2, which is both the P and Q will, do not have any acceleration, this is also incorrect. Now option number C, which says that P has a greater acceleration than Q, then it is correct, and the option number Q is obviously wrong. Most of the people are thinking that why didn't I use the formula V square by R? It is also due to the fact that V is also a variable and R is also a variable, and this V is different for P and Q and R is different for P and Q. So if there are two variables, so I could not relate them. So for having a relationship between the accelerations, I have used the formula r omega square, in which omega is constant for both of them and a radius is different. So it makes their comparison to be easy. Thank you. In this question, it is there are two paths. One is helical. This is this one, and this is a spiral helical. So there are two parts on which a particle is moving with a constant velocity, Now we have to choose the correct option. Now in this case 1, the radius is constant and velocity is also constant. It is given in the question. Therefore acceleration will be constant in magnitude. But in this case the radius is variable. You can see the radius will be variable but velocity will be constant. So the acceleration in this case, which is v square by r, so r is increasing as this particle is moving like that, so r will be increasing, and if r increases then acceleration decreases. So the option number A, the velocity of the particle is constant in both the cases. It is wrong, obviously, because the direction of the motion is changing. The magnitude of the acceleration of the particle is constant in both the cases. It is also incorrect. And the option number C, that the magnitude of acceleration is constant in A and it is decreasing in B, this is the correct option. And the option number D, that the magnitude of acceleration is decreasing continuously in both the cases, it is also the wrong choice. Thank you. In this question, it is given that there is a toy car which is initially rotating in a circle of radius 2a, but it is also given that it was initially attached with a elastic string of length a, whose length becomes 2a when it is being rotated due to the centrifugal force. So the time period of the rotation is given as this t, and let us assume that F force is acting in this spring or string, and the centrifugal force is m. M is the mass of the toy car, and r is the radius. Radius is 2a mr omega square, and this is omega 1 square. So this is F1. So F1 is balancing m into 2a omega 1 square. So this F1 will be the spring force, and spring force is equal to kx, where x is the additional compression or extension in the spring. So you can see that the natural length of this string is a, and currently its length is 2a. So the extension in this string is a, so F1 will be equal to k into a. So k into a will be equal to m into 2a omega 1 square, and omega 1 will be equal to k by 2m root, and this is 2 pi by t. Omega is 2 pi by the time period. Now in the second case, the toy car is being speeded up. Its angular velocity or angular speed is increased until it moves in a circle of radius 3a. Now when the new length is 3a and the original length is a, then this F2 will be balancing m into 3a omega 2 square, and this F2 will be equal to k into 2a, because the natural length was a and the total length at this time is 3a. So this is m into 3a omega 2 square. Now this is k, omega 2 will be equal to 2k by 3m root, and this will be equal to 2 pi by t2. Now if I name this equation as 1 and this as 2, and if I divide t2 by t1, then that would be equal to root 3 by 2, and t2 is t dash, so t dash will be equal to t into root 3 by 2. So the correct option will be option number B. Thank you.